A very warm good morning to all the respected dignitaries, our chief guest for today, guest of honor, esteemed speakers, dean, head of the institution, faculty members, research scholars, students, and participants across the country. On behalf of Amity University, Uttar Pradesh, and India Meteorological Department, IMD, New Delhi, I, Dr. Amrina, along with the entire organizing team, welcomes you all to an extremely knowledgeable and insightful orbital expedition of 1 month certificate course on basic of remote sensing application in climate change modeling on virtual mode from August 18 to September 19, 2022. Today, we begin our certificate course with the blessings of our Honorable Founder President, Sir Dr. Ashok K. Chauhan, who has the mission and vision of making India a superpower in the field of education. Our dynamic Honorable Chancellor, Dr. Atul Chauhan, who are ardently working to create centers of thought leadership across the world, where faculty, scientists, and brilliant students can explore and expand the frontiers of knowledge. We begin this insightful journey with the blessings of our Honorable Vice Chancellor, Madam, Professor Dr. Balvinder Shukla, who believes in bringing out the best in every member of Amity family, Professor D.K. Bandyopadhyay, Mentor, Amity Institute of Environmental Sciences, Amity University, Uttar Pradesh, who always supported us in all our endeavors. We begin this proceeding for today with the lighting of the lamp that signifies the acknowledgement and blessings. The lighting of lamp removes darkness, ignorance, unhappiness, and symbolizes abundance, prosperity, and knowledge. The lighting of an oil lamp is regarded as to bow down to knowledge and to the Almighty. We begin the ceremony with the lighting of lamp, accompanied by the incantation dedicated to this light of wisdom in our lives. May I request the guests to participate in the virtual lighting of the ceremonial lamp before starting today's proceeding.
में तार दे माँ।
Thank you so much. Dear participants, it's my pleasure to welcome you to this online one-month certificate course on Basic of Remote Sensing Application in Climate Change Modeling. We are very proud to have you here and hope that you will have very interesting sessions with much learning and sharing of experiences. I take this opportunity to welcome our eminent speakers, dignitaries, participants, students, faculty, colleagues, and staff members for joining today's event. I extend my deep regards and welcome to our chief guest for today, Dr. S.P. Agarwal, Director, Northeastern Space Application Center, Government of India, Department of Space, Meghalaya, for honoring us with his presence and enlightening us on the importance of remote sensing and climate change modeling. I take this privilege on behalf of Amity University, Uttar Pradesh, to welcome our guest of honor, Dr. Mutunjay Mahapatra, President IMS and Director General of Meteorology, India Meteorological Department, Government of India, for gracing the occasion and highlighting the significance of this course. My warm greetings and heartfelt gratitude to our beloved Vice Chancellor, Professor Dr. Balwindra Shukla Ma'am, for always being so inspiring and motivating and paving the path of success for all of us. This certificate course is her vision only that brought all of us together this day. I welcome our pillar of strength, Professor D.K. Bandopadhyay, sir, mentor of Natural Resources and Environmental Sciences domain, who always supported us in all our endeavors. Also, I would welcome Dr. S.P. Singh, sir, domain head for Natural Resources and Environmental Sciences, who constantly support us in all our academic activities. Once again, I extend my warm welcome to all present here. I'm sure that we all will gain lots of knowledge and to understand the usage of remote sensing application in the assessment of climate change. Now, I would request Dr. Renu Dhupar, Joint Coordinator, Amity Institute of Environmental Sciences, Amity University, Uttar Pradesh, to please introduce the certificate courses to our participants. Over to Renu, ma'am.
Thank you, Dr. Amrina. Thank you. Very warm good morning to everyone present here. I feel extremely glad to welcome everyone to this much awaited one-month certificate course on basics of remote sensing application in climate change modeling, which started from 18 August to 19 September 2022. It gives me immense pleasure to standing in front of you amongst the most esteemed personality who have won excellence in their respective fields, and they have come across the country to share their valuable knowledge on this topic with all the participants. With the blessing of our Honorable Founder President Dr. Ashok K. Chauhan, our Chancellor Dr. Atul Chauhan, and respected Vice Chancellor Ma'am, Professor Balwindra Shukla Ma'am, and mentor of AIES, Dr. D.K. Bandopadhyay, sir, I would like to extend a very warm welcome to all of you to this one-month online certificate course. Remote sensing refers to the acquisition of the data and information about the phenomena and the territory without a direct contact with it. It is an alternative to in situ observation. And these remote sensing techniques are used in numerous fields, including hydrology, ecology, meteorology, oceanography, geology, as well as military scope, intelligence, commercial, economic, and planning. Recently, this remote sensing has been used for improving understanding of the climate system and its changes. It enables to monitor the Earth's surface, oceans, and the atmosphere at several spatio-temporal scales, thus allowing climate system observation as well as to investigate climate-related process or long and short-term phenomena, as for example, deforestation or El Nino trends. These remote sensing tools is also very important to get the information and data in various fields like natural resource management, management of the agriculture practices related to land use, land conservation, and soil carbon stock. Also for the forest fire fighting operation in real-time decision support system and monitoring of the land cover and its changes over different temporal and spatial scales, even after disaster events. And this climate nowadays is basically defined as the average weather in a place. But nowadays, due to the interference of the human activities in environment, there is a disturbance in the climate which leads to various problems which directly disturbs the human health and the environment. So it includes various patterns of the temperature, precipitation, humidity, wind, and seasons. And this climate pattern plays a fundamental role in shaping the natural ecosystem and the human economics and culture that depend on them. Through this training program, basics of remote sensing application climate change modeling, our expert speakers give our hands-on training sessions and lectures which are dealt with the models through which we are capable to know about the changes which are comes in our environment. So this course will introduce the students to the state-of-the-art concept and practice of the remote sensing. It starts with the fundamentals of remote sensing and subsequently advanced method, which will be covered in all this 1 month certificate course. This course is designed to give comprehensive understanding on the application of remote sensing in solving the research problems. And upon completion, the participants should be able to use remote sensing satellite images and field data in their future research work. The primary objective of this course is to provide opportunities for academicians, researchers, practitioners, policymakers, research scholars, most important students to undergo training and to share and discuss their ideas and practice across a range of empirical, theoretical, and applied approaches in remote sensing and climate change modeling for environment sustainability. This certificate course aims to provide a interdisciplinary platform for all the students and research scholars and to discuss the most recent innovations, trends, and concerns, as well as the practical challenges that encountered and solutions adopted in the field of the meteorology and climate change modeling. The course will also discuss the various challenges of environment system that can be resolved with the climate change modeling with the help of the applications of the remote sensing. The themes of this 1 month certificate course includes: first is the climate history and climatology; second, basics of remote sensing and its application; third, synoptic and dynamic meteorology; fourth, climate change prediction and modeling; fifth, geospatial technology for ecosystem mapping; sixth is the role of machine learning in disaster and extreme events; and seventh is the impacts of climate change, its mitigation and adaptation. All these 7 themes will be discussed through the sessions, lectures, and the hands-on training with the expert and experienced faculty members all over the country. And we point out the need for future work and future system to make better use of remote sensing in these climate change studies. And luckily, in the present time, there is a number of opportunities which are available in the various fields of the environment, which are resolved with the help of this application. And I strongly feel that acting collectively is the need of the hour, and basically uniting our youth for a common cause can work a wonders. After the completion of this certificate course, it will help our youth to take a strong resolution on how they can move close towards the betterment and towards the management of their environment. This is all from my side, and thank you for being such a patient listener. Have a good day. Thank you. Namaskar. Over to Dr. Meena Sardar Khan.
Thank you, Renu ma'am, for highlighting and introducing the aim and the objective of the certificate course and how the participants will be benefited from this. Thank you so much. Moving on, I would now like to invite Dr. S.P. Singh, Director, Amity School of Natural Resources and Sustainable Development, to say a few words to the gathering.
Thank you, Dr. Amrina, for giving the opportunity to talk to me. With the blessing of founder presidents and vice chancellor and Bandyopadhyay ji, I think the faculty of environment science need really a great appreciations that they have taken initiatives for organizing such an important course. I'm also happy to see Dr. S.P. Agrawal Saab as a chief guest, and he in 2008 to 10 he was my teacher, and he taught me about water resources and all hazard things. So I'm glad to see him working in the Northeast. That was my alma mater in Assam, Meghalaya cadre. So welcome, S.P. Agrawal Saab. It is really a great memory for me. About the course objective, everything has been elaborated by Dr. Renu Differ, but I would like to say some of the points which I saw the program, and I saw that almost the experts from 15 organizations have been invited to arrange this, and they are covering a number of theme projects like climate history, basic of remote sensing, synoptic and dynamic meteorology, geospatial technology, role of machines, impact of climate change, and software training. So I think it is basically an orientation course. The topic is a very contemporary topic and climate change modules, and we know that not only the climate change, but any kind of modeling we do, the primary requirement of the GIS and remote sensing. But so simply GIS remote sensing is the tool for making anything of model or predictions. Why we require a modeling? Especially now we are facing a biggest problem of global warming and all that. And unless we have a proper accurate predictions, only then we can take the mitigations measures. So this GIS remote sensing is the only technique available to us that we can give a good accuracy of predictions for this. And we should also remember, this is one of the science which is moving at a very, very fast rate. Every next day it is changing it. So the refresher of these courses are very, very important to all of us. Beside this, you cannot work as a research scholar in a science movement when you are talking about the GIS without a GIS remote sensing. So this is very, very important. But how this simply GIS remote sensing can do a wonder? They can only do a wonder if you have a good historical data available for this. So that is also important. What kind of data you are procuring, what kind of satellite imagery you are procuring, only then you can appropriately put the application of GIS remote sensing for making a good model. So this is a good beginning. At least the kind of target people we have taken is a white people. So for them, at least they get a good orientation. I feel that this training program will give them good orientations and the concept of GIS remote sensing as well as the modeling also. That should be an objective of us, because this is a very advanced site and every day things are changing it. You require very kind of a specialization. I can assure you the faculty of environment science, that all faculty of AI GIS remote sensing as well as SRND will provide a full support to make this program very successful. We have a good lab for the software, so that will also be given the things. But first time you are doing all these things, we hope that there may be a lot of gaps, no doubt about it. And it is presumed that there should be a certain gap, but it is a good thing to all of us that we are entering a new dimensions, that we are taking such type of courses. Earlier, we are not taking this course from the NRSES. So I'm very happy to see, under the guidance of Dr. D.K. Bandyopadhyay Sahab, we are all doing an innovative work, which is very much exemplary to us. Keeping this, thank you very much. And I will continue to support with all my infrastructure and faculty for making this program successful. Thank you very much.
Thank you so much, sir, for your wonderful words and for motivating us. Moving on, ladies and gentlemen, I now humbly request Professor D.K. Bandyopadhyay, Chief Advisor, FPO, Chairman, Amity Law School, Mentor, Amity Institute of Environmental Sciences, Amity University, Uttar Pradesh, India, to address the gathering. Ladies and gentlemen, Professor Bandyopadhyay is a professor, scientific management researcher, and an academic administrator of repute, a gold medalist in his master's degree, a PhD in computer applications, a fellow from ESSEC Business School, Paris, and an inspiring professional. Professor Bandyopadhyay has served the Indian Institute of Forest Management, Bhopal, from 2004 to 2008 as a director. He introduces different academic courses and studies in the area of environmental sciences, climate change, and environmental accounting, including ecological taxes. Dr. D.K. Bandyopadhyay has spent 45 years of his career doing what he does best, inspiring students, academia, corporate and non-corporate heads and policymakers to raise their excellence to the next level. Professor Bandyopadhyay has over 70 research contributions and published many papers in reputed national and international journals and won many awards for those. He was second Vice Chancellor of the Guru Gobind Singh Indraprasth University from 2008 to 2013. Ladies and gentlemen, there is a lot to his credentials. Presently, as a mentor to Amity Institute of Environmental Sciences, he's constantly guiding us and helping us to achieve the best of our potentials. So may I now request Sir to say a few words to the gathering.
Thank you, Amrina. Thank you very much for taking the initiative. That's the word I'm just using it. Taking the initiative in venturing into such type of activities by providing 1 month certificate course, and that's a new initiative. We have been doing it for the last 1 year or so. So we can call them as a value addition courses. So those students, not only from Amity campuses, but also from outside campuses, on behalf of the Amity Institute of Environmental Sciences, on behalf of the domain of natural resources, I appreciate you for showing your interest when joining the certificate program. So all my congratulations goes to Dr. Renu Dhupar and her team. A team consisting of many faculty members from the domain of natural sciences, and with the strong support of Professor S.P. Singh, who is now the domain head. Now we are able to spearhead this type of activities in addition to our other many responsibilities. I'll be just not be able to give the justice if I do not mention that many thanks to Indian Meteorological Department. They came forward and they collaborated with us. We have signed an MOU with them. Now we are going to have lots of other activities with them. And I, on my personal behalf, on behalf of the entire Amity Universe, on behalf of our Honorable Founder President, Dr. Ashok K. Chauhan, on behalf of our Chancellor, very dynamic Chancellor, Dr. Atul Chauhan, our Vice Chancellor, Dr. Balminder Shukla, welcome you all on this virtual platform. So we are really grateful and thankful to Dr. Mrityunjay Mahapatra and also Dr. S.P. Agarwal. Welcome you, sir. Welcome for sparing your valuable time in terms of educating the future generation of the nation. And so your valuable awards will make a long list, understanding about this very important topic of remote sensing and its application on climate change modeling. Now we know that the global warming, induced climate changes has been taking place. Now all over the world, the researchers are going on, understanding of these things are going on, and we have seen that June-October monsoon floods caused a loss of $10 billion, to be the 7th costliest loss, we can say that. They also led to the death of 1,750 people, the most among the natural disaster last year in 2020. Cyclone Fani, which affected Odisha and Bangladesh, was the 10th most costly natural disaster in the world. Tropical cyclones have been the costliest natural catastrophe in the world in the last 2 decades. In 2018, 17, 12, 5, 4 cyclones accounted for nearly $919 billion of a total of $1.43 billion lost due to disasters. The year ended the costliest decade until now in terms of such disaster, with a loss of $2.98 trillion. The Asia Pacific region affected by earthquakes to tsunami, floods, and cyclones accounted for 1.3 billion. That's a 40% of the total loss. Now the question is coming, when we try to convert them into economic terms, how do you measure them? What are the different tools and techniques are available in measuring this type of losses? Now, point number 1, do we have some sort of a preventing measure? Can you predict them well in advance? Can you see them and observe them? So one way of doing it in understanding the different climatic zones, which is part and parcel of our of the certificate program. We know that we have got 7 types of climatic zones. A tropical climate, the moist climates extend north and south from the equator to about 15 degree to 25 degree latitude. Then dry climates, moist subtropical mid-latitude climates, moist continental mid-latitude climates, polar climates, and highlands climate. So this type of climatic zoning has already been done by the scientists, and we have all studied it in different form or other. Now, when we talk about climate models, it is generally known as General Circulation Model or GCM, and we use mathematical equation to characterize how energy and matter interact in different parts of the ocean, atmosphere, land. Scientists use climate models to understand complex Earth system. These models allow them to test hypotheses and draw conclusion on past and future climate system. This can help them determine whether abnormal weather events or storms are a result of changes in climate or not. For example, when predicting tropical cyclones during hurricane season, scientists can use climate models to predict the number of tropical storms that may form off the coast and in what region they are likely to make it landfall. Now, in this context, we can see that our remote sensing or satellite-based data are going to have been playing a greater and greater role. Now, how the satellite data are being captured, how their scales are being converted, the satellite capturing data scales within the now it's 4.4 meters type of grids we are talking about, and how this cutter scale can be converted to vector scale. And so once it is converted to vector scale, so data are available. When we do the modeling, we use those data as our initial values to feed into the model, and from there we proceed it in terms of modeling the climate. That's point number one. Now, point number two. Now we can see whenever a cyclone takes place in the Bay of Bengal or Arabian Sea, through satellite picture, we are able to see the eye of the cyclone and then movement trajectory, the way they move it. So well in advance, we can predict the direction of movement. That's the reason we can see today our great Indian Meteorological Department is able to see what is going to be the maximum speed of the cyclone, wind of the cyclone, what are going to be the direction of the movement of the cyclone, what are the and how long this cyclone is going to be continue, and when they are going to weaken. Now, this type of prediction is only possible through the study of modeling and also synoptic meteorology. The synoptic meteorology gives us the direction and through the satellite pictures, and so this type of thing are going to come in a big way. So, as a student of environmental sciences, you must be well aware how this thing happens. What are the different intricacies that lies in the remote sensing applications? How the remote sensing application takes place? How the geosystem can be developed using the remote sensing data? How the geographical information system can be developed? So there are hundreds of applications that we can see which are going to get the data from the remote sensing applications. And once the remote sensing applications are in place and we are able to get those data in a correct way, so a lot of researches are also going on. Now, fortunately, another form that is coming in the drone technology, that's of course not a part of this program, that is also actually helping us in a much greater way in terms of looking at the ground from a very, very, very short distance and not that much of a high distance. So these topics, now is a very old topic, because meteorology is one of the very oldest topic, and we can see that the different country has taken an initiative. Different types of grids have been created across the country and globally also. The World Meteorological Organization has been created in terms of promoting and understanding the climate and so on and so forth. Our great Indian meteorological departments having branches across the country. So we can see that we are no way lacking behind any of the countries in terms of application, remote sensing application. and also climate change model. Our numerical models, short range numerical models are very successful. Now, long range numerical model, people are still working. Now, I hope that within no time or within a very short span of time, we'll be able to break that, that things. Now, with these few words, dear students, those who are there, dear participants, once again, let us welcome, Dr. S.P. Agrawal ji, and also Dr. Mrityunjay Mahapatra ji, who is the Director General of Meteorology, and also S.P. Agrawal ji, Northeastern Space Application Center, Government of India, Uman Meghalaya. So I just, once again, I welcome you on behalf of our Honorable Founder President, because our Founder President all the time says, do something what others have not done it. You be the pioneer and not the follower. So this is one such, every activity shall we do it, we try to be the pioneer. This is one of that such type of activity which we initiated. And then he says, when Amity does something, Amity must create a class of doing something. So we have started doing the class over here, and this is all due to this motivation, guidance, and advices from our Honorable Founder President. And this is again, we get the echoing from the same thing from our Honorable Chancellor and the Honorable Founder, Honorable Vice Chancellor. So, Amarina, thank you very much once again.
Thank you, sir.
And thanks to all the faculty members of the Amity Institute of Environmental Sciences and the Natural Resource domains. I am not going to take their names, but certainly all my congratulations to them for taking this initiative, for making this to happen. I understand large number of participants have joined it, and I understand you are also charging from them, and that also indicates that how popular these programs are going to be. Many students have already registered. That's what I have been informed. So students, try to get maximum out of it and make your questions in the chat box. Get the answers from the experts who they will be taking the session, so that let it be, some extent dialogue-based session, not the monologue-based sessions. That's the way that I all the time talk about. So thank you very much. Thank you, Dr. Singh. Thank you for supporting and actively supporting this program. Thank you, Renu. Thank you all. Thank you very much.
Thank you, sir.
I think my thanks also goes to Dr. Tonu Jindal.
Thank you, sir.
Thank you so much,
Thank you,
sir,
sir.
for
Thank
your
you.
wonderful and motivating words, and of course, touching upon the very important aspect of this course, that how the remote sensing is so very important for the climate change modeling. Thank you so much, sir. Moving on, ladies and gentlemen, I am extremely humbled to invite our Vice Chancellor, ma'am, Professor Dr. Balwinder Shukla, Vice Chancellor, Amity University, Uttar Pradesh, India. So synonymous to the inspiration, motivation, and strength. A lady who has been a driving force, a hard taskmaster, an ocean of innovation and leadership, and forever aspiring us to rise high in life with wisdom and vision. As I mentioned earlier, this certificate course is a result of her vision. Ladies and gentlemen, Professor Balwinder Shukla is a PhD from Queen's University, United Kingdom. She has over 3 decades of rich scholarly experience in industry and academia. Dr. Shukla is a professor of entrepreneurship, leadership, and IT, and the Vice Chancellor of Amity University, Uttar Pradesh. She has been one of the key team members, spearheading and instrumental in the exponential growth of Amity Group engaged in higher education. Ma'am, who has been our guiding light and a source of continuous inspiration, is an excellent administrator who leads by example. A moment with her is a moment of getting inspired, getting motivated, and getting thrilled by her untiring enthusiasm and dedication towards the betterment of university and society. She is an epitome of love, passion, and compassion. She is a goldsmith who polishes each one of us and led us towards excellence. With all due respect, may I now request ma'am to say a few words and blessings.
Very much.
Good morning, ma'am.
Good morning.
A very good morning to everybody. A very esteemed Honorable Chief Guest, Dr. S.P. Agrawal ji, Director, Northeastern Space Application Center, Government of India, and Department of Space, Meghalaya. A very honorable guest of honor, Dr. Mrityunjay Mahapatra, President, IMS and Director General, of Meteorology, Indian Meteorological Department, Government of India, my esteemed colleagues, Dr. Bandyopadhyay, Chief Advisor to Founder President and Chairman, Amity Law Schools, Professor S.P. Singh, the Domain Head of Amity School of Natural Resources and Sustainable Development, Dr. Amrina, Dr. Renu, all the faculty members and the participants. I, on behalf of Honorable Founder President, Honorable Chancellor, and all my colleagues, I extend very warm welcome to our Honorable Chief Guest, our Honorable Guest of Honor, and all the participants for the inaugural session of 1 month certificate course on the basics of remote sensing application climate change modeling. As we all know that climate change has become a very big challenge for the survival of humanity for the long term. How the appropriate actions be taken to ensure that that the climate change is handled properly, and one of the technology which can be used is the remote sensing application in climate change modeling. And so I would like to congratulate the team from Amity Institute of Environment Sciences for choosing this very apt theme for the 1 month certificate course. Um, as we all know and understand that the climate change is the long-term shift in the temperatures and the weather patterns across the globe. This shift um, are natural for the um, centuries and epochs. However, in the recent times, these changes are not only natural through the variation in the solar cycle, but are also many other due to the human activities, where the tampering with the mm, with the with the natural system, and which can be maybe because of the human beings needs for better and better um, lives facilities. So whether it was the industrialization, whether it was um, the creating the all kind of the facility, the transports, the power, electricity. So where the burning of the fossil fuels like coal, oil, and gas became one of the important aspects. Second has been also that the deforestation and the constructions of the buildings and creating the uh, brick jungles, and which also the extraction of the groundwater, excess groundwater, which have also led to the changes in the climate, and which have the direct adverse impact on the society, on the humanity, and which is also led to the drought in many of the regions, and which has affected the food production and the human health adversely. Another because of the deforestation and other aspects have led to the um, flooding, and which also leads to the disease spread and damages to the ecosystem and the infrastructure, um, and which further impacts the human health, which can increase the mortality or impact the food availability or the limit the worker productivity. So therefore, the climate change impacts are uneven across the country and the world, and even within the single community, climate change impacts can differ between the neighborhoods or the individuals, depending on the individual sensitivity. And therefore, the climate models are very important tool for improving our understanding and predictability of climate behavior on the seasonal, annual, regional, or the decadal or the centennial time scales. Models investigate the degree to which observed climate changes may be due to the natural variability or human activity, or a combination of both. Their results and projections provide essential information to better decision making at the national, international, regional, or the local levels. So which can help in the resource management, water management, agriculture, transport, urban planning, and the other aspects. So therefore, these uh, scientists across the globe use the climate models to understand this complex Earth system, and therefore these models also allow them to test the hypothesis and draw conclusion on past and future climate change. Though we know that many times the meteorological department, forecasts the rain of particular day, but we do not see the rain on that day, and the meteorological department forecast is going to be, the sunny day, but we see the heavy showers coming. So these are all the tools which, when we talk about whether it's the remote sensing and others, they can help uh, to uh, to some extent, but the nature is nature at the end, and accurate prediction is always an issue. And however, but when we look at the long term, we have seen the impact. um, if you see that even the local region like Noida, and we see that how the, you will see in the some region of the city, you see the heavy rainfall, and where the other part of the, just 1 kilometer away, you will see that there's a just the full sunny day. So it is the micro level predictions happening, is a very very challenging, and therefore the more accurate system need to be developed, and by gauging um, the the all aspects, whether it's the wind, whether it's the clouds, whether it's the humidity, or whether all aspects, how they move, and so understanding their behavior, and based on their behavior, how that is going to impact a particular region, a particular zone, in for the long term, and more accurate or the powerful tools uh, are required. The remote sensing can play extremely um important role. So remote sensing techniques, and specifically satellite images, have been used to a great level, and which have studied the wide range of the climate changes, whether it's investigating the global temperature trends both in ocean surface and in the atmosphere, or detecting the changes in solar radiation affecting the global warming, or monitoring the aerosols, water vapor concentration, and changes in the participation regimes, or studying the dynamic of snow extension and ice covers, or whether covering the sea level changes and the coastal modifications, and or whether it's monitoring the vegetation status and the changes, and monitoring the water source and impact due to drought and the dry periods, because it directly impact the humanity and the agriculture, other aspects, or monitoring the fire events and the fire emissions, and also it helps in the predicting the disaster risks such as cyclones, floods, and the droughts. And ultimately, it helps in guiding the decision-making process on climate change adoptions. And therefore, this workshop, 1 month workshop on the very important topic, the basics of remote sensing application in climate change modeling, will definitely help in developing the future talent, understanding its importance and how they can apply the knowledge gained out of this workshop in the various applications. So once again, I would like to congratulate AIS, and I am extremely thankful to our guest of honor, our honorable chief guest and our honorable guest of honor, for sparing their time and being with us to inaugurate the session. So um, your presence will not only inspire the participants, but it will also give deep knowledge about the topic, because when we look at the Northeastern Space Application Center, Meghalaya, um, that because a lot of work is being done by your esteemed organization, and we like to explore the possibilities of working with your center in the various research areas in the space application, and how the academic institution and your research organization can work together. So, Dr. Agrawal, we look forward your guidance and that how we can work together. And Dr. Mrityunjay Mahapatra, the president of IMS, since the meteorology is extremely important aspects when we look at the climate related aspects, and working together with your organization will help the researcher scientists and the scholars to understand mm, the scientific aspects in a deeper way, and developing the future talent for the in this sector. So we like to explore the possibility of how we can work together. Once again, I extend very warm welcome to our distinguished guests. Our honorable founder president have always emphasized that developing the synergies and developing the collaborations for the common goal, which contribute to the nation building and making India the self-reliant and having the technological advancements. I think therefore the time has come when the academic institution and the research organization to work together. Our honorable chancellor has always emphasized the synergy of the various organizations in a specific field can make the uh, huge impact and changing the world, changing the society in the positive sense. So therefore, we'd like to work together with you and to make that desired change to make the India self-reliant and technologically highly advanced country and be fully developed. Our Honorable Prime Minister, in his recent speech on 15th August, have said that the next 25 years are the Amrit Kal. And how do we work together in that Amrit Kal, that we make the India the global leader, not only India as a self-reliant, fully developed, but the global leader. Therefore, the working together as a in the research area and other areas is extremely important. To all the participants, I would advise that your institution, your organizations have nominated you to attend this workshop. So you people make best use of this opportunity and make sure that you have gained the knowledge and which you can apply in the various facets. With this, once again, extend very warm welcome and and wish all the best for the success of this 1 month long certificate course. Thank you very much.
Thank you, ma'am. Thank you so
Thank
much
you
for
so
inspiring
much.
words, ma'am.
Thank you so much, ma'am, for inspiring us always and taking the perspective of synergy from ma'am and her energy. We move forward to our next speaker, our guest of honor for today. Ladies and gentlemen, I'm feeling so privileged and honored to invite our guest of honor, Dr. Mrityunjay Mohapatra, President, India Meteorological Society and Director General of Meteorology, Indian Meteorological Department, Government of India. Ladies and gentlemen, he is the Director General of Meteorology, IMD India, and permanent representative of India with World Meteorological Organization and member of Executive Council, World Meteorological Organization. With a PhD in physics and 28 years of experience in meteorology, he has made significant contributions in improvement of early warning services of IMD. He brought laurels to country from international agencies for effective cyclone warning. He is popularly known as the Cyclone Man of India. He is the author of more than 105 research papers in peer-reviewed national international journals and edited 18 books and 7 journals. Currently, he is President, India Meteorological Society, Chairman, Regional Sub-Project Management Team of Severe Weather Forecast Program for South Asia, and was a chairman of World Meteorological Organization Panel on Tropical Cyclone. Task Team for finalization of meteorological payloads of INSET-4 satellites to be launched in 2025. Committee for revision of NDMA guidelines for cyclone management. Technical Evaluation Committee for consultancy on National Cyclone Risk Mitigation Project. Before I invite Sir to speak, we would like to felicitate Sir with the Tulsi sapling, a wonderful tradition of Amity University, Uttar Pradesh, to cherish this develop bonds and love and friendship. So I request Bandopadhyay sir to please present the virtual sapling to our guest of honor for today. So please accept our virtual Tulsi sapling. Over to you, sir.
Welcome, sir. Welcome.
Welcome,
Namaskar.
welcome.
Welcome, sir.
Namaskar, good afternoon to all of you.
Thank
Yeah.
you,
Thank
sir.
you, sir.
My dear friend, Dr. S.P. Agarwal, Director, Northeast Space Application Center, ISRO, and Professor Malvinder Shukla, Madam, Vice Chancellor, Amity University, Uttar Pradesh, Professor D.K. Bandopadhyay, Chief Advisor, Chairman, Amity Law School, Professor S.P. Singh, Domain Head, Amity School of Natural Resources and Sustainable Development, Dr. Renu Dhupar, Joint Coordinator, IAS AUUP, Dr. Amrina Sardar Khan, ladies and gentlemen, distinguished faculty members, participants in this workshop, and dear students. At the outset, I express heartiest congratulations to the organizers, especially the authorities in Amity University, for taking up this very important training program, that is basics of remote sensing applications in climate change modeling. And I'm also really feeling happy that all concerned departments are involved in this program, including ISRO, India Meteorological Department. And I'll just make one correction, that I am no longer president of Indian Meteorological Society. I was for the last 2 years up to March, and from April, the new body has taken up. I am the past president of the Indian Met Society. So coming to the topic, this topic is very relevant. As all of us know that we all are worried about the climate change, and we all think about the impacts of climate change. But when we analyze actually climate change, there are 3 important aspects. One is the science of climate change. Then second one is the adaptations. And third one is the mitigations. And as we are all in a scientific community, we basically deal with the science of climate change. And science of climate change again consists of 3 important facts. The first one is the detection. So at first and foremost objective is that we should detect whether there is any climate change or not. And the detection itself consists of many processes, the direct observations, remotely sensed observations, and also the, you can say, sample-based observations to analyze the historical data sets and hence derive whether there is a climate change or not. Because climate is changing always. Climate has changed in the past, climate is changing now, and climate will change in future. So what do you mean by climate change now, which is what we are talking of? This is the enhanced rate of climate change, which is popularly called as growth. So we have to find this enhanced rate of climate change is different from the natural variability, is different from natural climate change. So that study or that science is called as the detection of the climate change. And there are many studies within India and outside also. And officially, India Meteorological Department is the agency to say whether there is a climate change in the past 100 years or 120 years based on the observational data. Okay. And the Minister of Environment, Forest and Climate Change is the nodal agency who utilize the scientific facts provided by Minister of Earth Sciences, IMD. So while doing so, for the past observations, we are dependent on ISRO. Indian Space Research Organizations provide the remotely sensed observations to for so many years since 1982. But prior to that, within INSAT satellite, but prior to that, we have the access to the foreign satellites since 1960. So we have got the database about the various types of severe weather events occurring in the remote areas like Bay of Bengal, Arabian Sea, Indian Oceans, especially the cyclones and depressions, more accurately with the help of this satellite data since 1960. And also the same case for the remote areas like Himalayas. So considering India as a country which is surrounded by the great Himalayas and Bay of Bengal, Arabian Sea, Indian Ocean to the east, west, and to the south, and having the major physiographical structures like East Coast, Eastern Ghats, Western Ghats, Garakasi-Jaintia Hills, Myanmar Hills, and the big deserts like Thar deserts, we are largely data sparse. So therefore, we depend largely also on the remote sensed observations like satellites and radars. And satellite provides a continuous observations from, as I told you, from 1960 and 1982 with Indian satellites. And radar-based observations come up a long way, starting with 2004, the deployed radars. But in 1970 onwards, we've got the radar observations. Inaugural radars came into picture in 1970 when INSAT was not there. We have got all the radars along the east coast and west coast, and hence no cyclone could escape outside the radar arena since 1973. It was based on the cabinet committee decision after the massive cyclone which devastated Andhra and Odisha in 1970 and 71. So we have a large amount of data set with respect to remote sensing, and all these are used to provide the information on a longer time series, and hence to find out whether there is enhanced changes to attribute that it is a climate change. So once you have done that detection, the next step comes the attribution. The attribution means you have to find out the factors which has led to this type of climate change or this type of observations, if at all you have. So what is the observation actually? Over the country as a whole, if you just look at, or if you look at South Asia, you find that, yes, there is an impact of the climate change and there is an increase in extreme weather events like frequency of severe tropical cyclones over the Arabian Sea, or the frequency of heavy rainfall events over the country, or the frequency of heat wave and its duration over the country. Though cold wave is decreasing, but variability is increasing, and hence we cannot rule out the cold wave, and cold wave also occurs in the country. The frequency of lightning has increased, frequency of thunderstorm has increased, and hence we are more prone now towards all these severe weather events. Consider sea areas, yes, there is an increase in the sea surface temperature, and also the ocean heat content of the temperature. And this sea area is a major observational platform to determine the climatic variations, because the sea parameters like sea surface temperature or ocean heat content has the larger memory. It does not change one-to-one because the heat capacity of water is 1, the maximum. So therefore, the temperature does not change so rapidly as the temperature changes over the Earth's surface. So if you see the morning temperature, it may be around 20 degrees Celsius, and in the evening and the afternoon, it may be 35 degrees Celsius. There is a variation of 15 degrees Celsius within a day itself. But that does not happen in the sea surface. It hardly varies by 1 degree Celsius. So because of this, the sea has got a longer memory. And that longer memory of the sea observations helps us to monitor the climate. So therefore, any climate modeling, any climate change modeling is largely dependent upon the observations from the sea surface. And these observations from the sea surface are now largely being connected with the remotely sensed observations like satellites. The satellites also can collect the observations like sea surface temperature or ocean heat content, or you can find out depth of say 26 degrees Celsius. So many parameters, many more parameters. Apart from atmospheric parameters, oceanic parameters also can be derived from all these satellite-based informations. And where where India is contributing a large through ISRO and IMD collaborations. And of course, nowadays the data are available to many research organizations, and through this platform, the research organizations can utilize all these informations to have the more R&D work. So while doing that, then you have to go for some kind of modeling to address that it is because of certain impact of the climate change, attribution part I was just talking about. So that means you have to see what is the relationship of the increase in carbon dioxide or methane gases or any other greenhouse gases with the frequency of occurrence of the various types of extreme weather events or the changes in the parameters in the Himalayas or in the parameters in the sea areas. Of course, there are changes in parameters in the Himalayas also, like the glacier retreats and etc. And the frequency of the western disturbances affecting the western Himalayan region and etc. So, so for that purpose, modeling comes into picture. You have to consider the past data, you have to model the system, and you have to validate whether it is really because of all these greenhouse gases. The study shows that, yes, certain cases can be attributed to greenhouse gases, like the enhanced genesis of the tropical cyclones, sea tropical cyclones, Arabian Sea, can be attributed towards the impact of the greenhouse gas concentration increase, and the confidence of the scientists towards that is low, not high confidence, not high confidence. With a low probability, the scientific community says that frequency of increase in intense cyclones over the Arabian Sea can be attributed towards the climate change. But when you consider the heavy rainfall events which is occurring over the country during monsoon season, especially in association with the low pressure systems developing over Bay of Bengal and moving westwards towards Gujarat and Rajasthan, it is found that it can be attributed towards the climate change. The climate change has led to increase in frequency and intensity of the heavy rainfall events during monsoon season. Basically because it makes the environment more favorable for convective activity by increasing the instability in the atmosphere, by increasing the atmospheric moisture load. Now, once the temperature increases in the atmosphere, it has got the better capacity to hold the moisture. And hence when it rains heavily. So number decreased, but number of heavy rainfall days has increased in recent years. Not a sweeping statement for entire country, but in many parts. Okay. And it's also there in case of urban flooding, in case of the flash flooding, etc., that we find. And it is not the only reason for that purpose. There are also man-made regions which leads to that type of urban flooding or flash flooding or landslides, more prone towards the heavy rainfall events in association with the low pressure systems during monsoon season because of the impact of this climate change. Similarly, the study says that as the temperature rises, the atmosphere becomes unstable. The proneness towards occurrence of more frequent thunderstorms also increases, and in certain parts also frequency of lightning shows increasing trend in the country. So with all these detection and attribution, the next comes the projections. So how to project? How will you find out what will happen to the frequency of extreme weather events, or what will happen to the sea surface temperature, what will happen to the glaciers, what will happen to the snow cover by 2050 or 2100? So that science is called as the projection. And in the projection, there are various scenarios which are, it is not a prediction I'm talking about you. It is always a projection. Projection is not prediction. This projection is based on certain assumptions. And that assumption is that what will be the radiative forcing in the atmosphere and ocean because of the increase in concentration of greenhouse gases. So IPCC, which takes into consideration all the data, even IMD also provides data to IPCC and WMO. So they have come up, as all of us know, that the various scenarios, the RCP scenarios, and based on that, say 8.5 or 4.5 or as usual, whatever it is, and people go for trying what will be the climate change. I'm happy to inform you that for the first time in this particular IPCC statement, the Earth system model run by Minister of Earth Sciences through Indian Institute of Tropical Meteorology has been taken into consideration. So there are many agencies which are running our system models. So therefore, there will be different models, and the models differ also. There will be uncertainty also in model assessment. But whatever it may be, it is a good news that we are a part and parcel of this modeling activity. We are also calculating the projections. And the projection says that, yes, monsoon will be more active in a changing scenario, in a hot scenario, and hence more frequent heavy rainfall events we can expect during monsoon season in the years to come. And also at the time, it says that variability will increase, that means more frequent floods and more frequent droughts we can. And of course, the events like the cyclones and heavy rainfall and thunderstorms are expected to increase in intensity. But frequency of cyclone is not expected to increase, and also it has not increased globally. The cyclone frequency has decreased, but intensity, rate of intensification in certain areas like Northwest Pacific, North Atlantic, and Arabian Sea has increased. So this is a massive science. Those who are interested, they can continue their work. There are two types of climate modeling or climate change modeling. One is the global climate change modeling, which is being done by the help of the Earth system models. People are trying to improve the resolution. People are trying to improve the data assimilations. People are trying to validations. That work is going on. But in the university scale, but in the certain institutes, you can go for regional climate modeling. In the regional climate modeling, you can focus on what is going to happen in different scenarios. And for that purpose, codex data are available, and IITM is providing codex data, and people can go for regional climate modeling, and they can find out what is going to happen in different specific areas, like, say, for example, states or homogeneous regions or the districts for the years to come. And that will certainly help once you come up with the science of climate change that helps in adaptations and mitigations. So adaptation and mitigation measures can be more fine-tuned with all this information. So as all of us know that Honorable Prime Minister has taken up the climate change action plans, 10-point action plans. And under that, various actions are being taken up for adaptation and mitigations. So our role as scientists, working in academia, R&D, and the nodal agencies is to provide the authentic sources of informations and authentic informations about the climate change with the help of the detection studies, the attribution studies, and the projection studies using various models and the past data. So I hope this particular workshop will be very helpful, and it will bring out the enhancement in knowledge base, and also it will provide a platform for interaction with each other, and we can proceed further with more capacity building so that we can address the huge requirement of climate change modeling. So thank you very much. Wish you all the best.
Thank you, sir. Thank you.
Thank you so much, sir. Thank you for highlighting the importance of remote sensing applications, its model for climate change prediction and projection. And indeed, there's a lot to take from your deliberation. Now, moving on, ladies and gentlemen, I'm extremely humbled to invite our chief guest, Dr. S.P. Agarwal, Director, Northeastern Space Application Center, Government of India, Department of Space, UMM Meghalaya, to address the gathering. Ladies and gentlemen, Dr. S.P. Agarwal assumed the charge of Director NESAC with effect from 17 September 2021. He served as the Group Head of Water Resources Department at Indian Institute of Remote Sensing, ISRO, Dehradun. Before joining NESAC, Dr. Agarwal is a highly accomplished scientist in the field of remote sensing and GIS applications in water resources management, disaster management, and climate change impact assessment. And at the same time, he has immensely contributed to the capacity building and outreach program of ISRO. He obtained his BTech degree in agriculture engineering from Allahabad University, postgraduate and PhD degree from Indian Agriculture Research Institute, New Delhi. He did his postdoctoral research from ITC-IHE, the Netherlands, in the field of hydrological modeling. He started his career at IIRS in 1996 and has contributed significantly in the field of remote sensing and GIS application in water resources management, disaster management, and climate change impact assessment on hydrological regime. He has successfully led several regional and national projects covering large-scale hydrological modeling, irrigation water management, soil erosion assessment, snow, ice and glacier melt studies, flood mapping, monitoring and flood early warning system, cryosphere research in Antarctica and Arctic region, etc. He demonstrated exemplary leadership in simultaneous progress of the group in research applications and capacity building arena. Dr. Agarwal is an active member of several scientific and professional societies. He is serving as Secretary of Technical Commission 5 of International Society of Photogrammetry and Remote Sensing on Education and Outreach. He served Indian Society of Remote Sensing as Secretary for 4 years and Treasurer for 2 years. He is currently contributing to the Journal of Indian Society of Remote Sensing as Managing Editor. He also had successfully organized Asian Conference on Remote Sensing on space application touching human lives with about 1,000 delegates from 53 countries as organizing secretary. He has more than 150 research publications in peer-reviewed international and national journals and conference proceedings. He also authored 4 book chapters and 9 technical reports. He has visited several countries to attend conferences and meetings that had helped strengthening international linkages and cooperation. So we are so honored to have you here. But before I invite you to give your deliberation to our August gathering, we would like to felicitate you with a Tulsi sapling, a wonderful cultural and traditional practice of our university to cherish the bond. Our respected Vice Chancellor Madam is presenting you a virtual sapling. So we request you to accept it.
Thank you. With humble and honor, I accept it. Thank you very much.
Welcome, sir.
So thank you, Dr. Amarina. Indeed, it is my honor and privilege to be with you online as a chief guest on the occasion of inaugural function of basics of remote sensing application in climate change modeling. First of all, I would like to compliment the organizers, the president of the MIT University, the chancellor, the vice chancellor, dignitaries of the MIT University and the professors of MIT University to organize this very, very important, in fact, to select this very important topic. In fact, it is a need of the hour. If I see the climate change studies as well as that, remote sensing application, I found in our country, which is having population of 135 crores of people, there is a need, very less manpower of, who understand this climate change and how to utilize the space technology for climate change study. So I fully compliment, and I could able to hear the entire your program. And I compliment you that how comprehensively you designed your program. I'm sure this program is going to be very, very good, and it will show the path to other people also that how to, organize a program. So my best wishes to all of you. Now let us come to the topic of today, basically remote sensing and GIS. But before that, it is my honor to sit besides one of the most important person, man of the hour, or shall I say man of the day, or I say man of the season. It is Dr. Mahapatra. Dr. Mahapatra is good friend of mine, and always, he helped us when I was at IRS. We used to invite him for such type of lectures, and his lectures is always, it's a feast of our ear and the brain. So thank you, Dr. Mahapatra, for being here as a guest of honor. Honorable Vice Chancellor of the University, Dr. Professor Balvinder Shukla, Madam, Chief Advisor FPO and the mentor MIT Institute of Environmental Science, Professor D.K. Bandyopadhyay, Professor Santosh Pal Singh Ji, Domain Head, MIT School of Natural Resource and Sustainable Development, Dr. Renu and Dr. Amarina, and dear course participants. As you are aware, climate is a very complex phenomenon. When we talk about the climate, basically we have to think about the entire climate system. So climate system consists of 5 major components. One is the atmosphere, where we call it gases or water vapor. Then geospheres, where lands, surface and subsurface. Then biosphere, like vegetation or human being. Hydrosphere, where like ocean, river, lake, reservoir. And the cryosphere, where snow, ice and glaciers. So the climate system, it's a very complex. There are multiple interactions between all these 5 major components, like atmosphere to land, land to atmosphere, land to cryosphere, cryosphere to atmosphere, atmosphere to cryosphere, hydrosphere and ocean. This is a very complex system. Okay. And not only that, climate system forced or influenced by various external forcing mechanism. The most important one is the sun. Also, the direct effect of human activities on the climate system is considered an external forcing, and which is playing a very critical role in climate change studies. Satellite for climate change studies. Now the question arises that what is the importance of remote sensing or satellites for climate change studies? You know that satellites provide the wide area observation capability. You know, a single instrument on a polar orbiting satellite can observe the entire Earth on a daily basis. Okay, while on instrument on geostationary satellite continuously monitor the diurnal changes within the atmosphere of the Earth. Okay, then not only that, it is a non-intrusive observation. It allows a collection of the data no matter which country. There is no political boundaries. Okay, then since it is the same sensor, so uniformity of the data will be there. It provides the rapid measurement and the continuity. So continuity with single sensor or series of sensors. So already Dr. Mahapatra was telling, now we have the satellite data or radar data since 60s or 70s. So generally for climate change, 50 years data is sufficient, or it is sufficient. So now satellite-based data is available for climate change studies. To understand the climate system and the climate change, there are essential climate variables. You know that. So these essential climate variables is a physical, chemical, and biological variables, or a group of linked variables that critically contribute to characterization of the Earth's climate. And this we have to understand. So what are those ECVs? So those ECVs I can divide into three categories. First one, the ECV for atmosphere. Okay, so atmosphere means over land and sea and ice. So generally, again, further I can divide into three categories. That ECV for surface, like air temperature, wind speed, wind direction, water vapor, pressure, precipitation, surface radiation budget. This is the surface. Upper air, like temperature, wind speed, direction, water vapor, cloud properties, earth radiation budget. Then composition like carbon dioxide, methane, and other long-lived greenhouse gases, ozone, aerosol. Okay, so these are all, you know, ECVs for atmosphere. And this ECV we should map and monitor. Another one is the ocean. Ocean is very, very important as far as climate is concerned. Okay, and as already told by Dr. Mahapatra, it has a long memory. It is very, very important. In fact, our all monsoonal activities are directly linked with the properties of the ocean. So there are surface properties, ECVs, like sea surface temperature, sea surface salinity, sea level, sea state, sea ice, surface current, ocean color, carbon dioxide, partial pressure, ocean acidity, phytoplankton in the ocean. Subsurface like temperature, salinity, current of the subsurface, the nutrients, carbon dioxide, partial pressure, ocean acidity, oxygen, many things are there. So these are the ECV for ocean. Then comes the ECV for terrestrial, like land, land use land cover. Fraction of absorbed photosynthetically active radiation, we call FPAR, leaf area index, above ground biomass, soil carbon, fire disturbances, soil moisture, hydrosphere like lakes, river, water, groundwater, cryosphere, snow cover, glacier, ice caps, ice sheet, permafrost, albedo, etc. Now you see, to understand the climate, we need so many parameters, not only for atmosphere, but ocean and terrestrial. But if I am telling all these things, you will realize that many of them can be captured, mapped, and monitored by remote sensing. Okay, so, but then there are some indicators like glacier retreat, change in polar ice cover, change in sea ice, sea level rise, okay, desertification, increase in the disaster, then monitoring the agents like greenhouse gases, carbon dioxide, nitrous oxide, methane, then increase in the terrestrial carbon, okay, aerosols, trace gases, then impact, like what is going to happen if climate change will happen for food security, water security, environmental security. So this we have to understand. Now, to do so, there are many satellites. You know that India has different kind of satellites. If you are looking for the impact, for example, like what is the impact of climate change on water resources? So you want to map. For that, we are having ResourceSat-2, ResourceSat-2A satellites. Forest cover mapping, we have a ResourceSat-2, 2A satellite. Flood mapping, no, disaster flood mapping, monitoring, landslide. We are having not only ResourceSat, but even damage assessment. We are having high resolution satellite like Cartosat-1, Cartosat-2, Cartosat-3, which is having resolution of only 30 centimeter, 25 centimeter. We are having different satellites, like for example, glacier retreat. You can either use ResourceSat-2, where the sensor list4 is very, very useful, which is having 5.8 meter resolution. Or even you can use the Cartosat-2 satellite, which is having resolution of 65 centimeter. Now, any other kind of changes can also be mapped. We are having satellite for ocean like OceanSat-2. And not only that, if sea level rise, we are having satellite of Saraleltica. Then that ocean winds, we are having satellite SCATSat. In fact, our SCATSat data is used by entire world, including NASA also, including US also. Okay, so these satellites are there. Then comes the weather satellite. Already Dr. Mahapatra has spoken about the linkages between ISRO and IMD. And you know that every day I'm looking at IMD website to see the cloud condition, and then only I see what is going to happen in Northeast region, because we are responsible for FLUS, flood early warning system, and we provide the data to the what do you call this state disaster management authorities, that at 24 hours before or 48 hours before that, whether it is going to be flood or not. So we are generating 4 types of alert. One is that advisory, watch. Second one is that low flood alert. Third one is the moderate level flood, and fourth one is the high level severe flood. So this we are, we are using different models. WRF model we are using. At NESEC we are having, that the HPC, which really we are having 152 core HPC here, and we are running WRF model. But also, in fact, once I discussed with Dr. Mahapatra also, we wanted to get the data, that predicted data from IMD, because they are having a very robust and very accurate model nowadays, I can tell you, and that can be incorporated in our FLU system. So every day I'm looking at the IMD website, and I'm finding what is the cloud cover condition, cloud top temperature, that wind vectors, all these things I get from IMD. Okay, so these many things you get from the satellites. Okay, let us move further. But then these are our Indian satellite. There are many foreign satellite. Now you may be wondering that how to get the carbon dioxide. So I would like to tell you there are 2 satellites. Earlier it was OCO2, and now in 2019 OCO3 was launched. Now OCO2, that this satellite, orbiting carbon observatory, and it gives you the carbon dioxide, and the grid size is around 4 kilometer by 4 kilometer. Essentially 2 miles by 2 miles, and every around 4 kilometer by 4 kilometer you get the carbon dioxide. So OCO3 is now available, and you get the data. Okay, so in fact it mapped the entire Earth in 16 days. So every 16 days you can measure the carbon dioxide using these satellites. There are many more satellites like ICESat. Now ICESat-2 is there. Okay, which measures the ice condition everywhere, not only the ice condition, basically it's ice, cloud, and land elevation satellites. Then there is a CryoSat satellite also for cryosphere. Then there is a CloudSat satellite. The CloudSat satellite is nothing, so it is having a radar. It is a cloud profiling radar it has, which is very, very accurate, and it gives the cloud condition, raindrop size of any rain. Then we have a Calypso satellites. This is from foreign countries actually. So Calypso stands for Cloud Aerosol Radar Infrared Pathfinder Satellite Observation. Okay, and this satellite provides the cloud information and aerosol information. Then there is a SMOS, soil moisture and ocean salinity. When climate change will happen, lot of temperature increases, evaporation will increase. So it will simply influence the ocean salinity, and which is further influence the ocean circulation. So then we will have an impact on the monsoon. So ocean salinity is very, very important, and soil moisture on the land, which is the feedback to the atmosphere. So SMOS satellite is now available. This is the soil moisture and ocean salinity satellite. There is another satellite, which is by European agency, Sentinel-5, commonly known as TROPOMI. It monitors the air pollution, like not only that, ozone, methane, aerosol, carbon monoxide, nitrous oxide, sulfur dioxide. So this satellite is also available. Then there is a, any moisture or, regime anomalies. So GRACE follow-on satellite is there now. Earlier it was GRACE 1. Then MODIS, sensor of Aqua and Terra satellites. It is giving lot of the atmospheric product like total precipitable water, then atmospheric profile, then, cloud, all these information it gives. Then lot of, cryo related like snow cover, CIS cover it gives. Then, Aura satellite, it is there, and it gives it monitor the Earth's ozone layer, air quality and climate. Then there a METOP satellite is also there, which gives the meteorological parameter. Not only that, it helps the information available help in numerical weather predictions. Okay. So, I will keep on telling about these. Hundreds of satellites are available for climate change. And I'm so sure that you are going to talk about all these things, how to get the information for, this climate change study. Another very important satellite which people are using, this is the Suomi NPP, Suomi National Polar Orbiting Partnership Satellite. And this satellite is civilian weather forecasting. It is a replacement for NOAA polar satellite. And that the satellites orbit Earth about 40 times each day. And it is having many sensors, which includes the ATMS, Advanced Technology Microwave Sounder, Cross-Track Infrared Sounder, Ozone Mapping and Profile Suite, Visual Infrared Imaging Radiometer Suite, Cloud and Earth Radiation Energy System. So you see, when we are talking about the climate system, these satellites give you a lot of information. Okay, and of course, our mega tropics is also, GPM, Global Precipitation Mission. So Global Precipitation Mission is constellation of different satellites from different countries, and there one Indian satellite is there, that is mega tropics, and it provides the rainfall information. Okay, so this, if you are interested in GPMs, you can collect the IMERG data, and you will get rainfall information from these satellites. For India, like OceanSat-2, it gives the surface winds and ocean surface strata, observation of chlorophyll concentration, monitoring of phytoplankton blooms, study of atmospheric aerosol, suspended sediment in the water. So you see, it is having different sensors like OCM, spectrometer, ROSA, all these sensors. Analytica already I told, and of course inside 3D, 3DR, I'm not going to tell, because every day you are getting information about the rain, cloud from this only. Okay, but if I keep on counting all these satellites, there are hundreds of satellites available, and I'm sure a lot of data, freely data is. People ask me, where is the data? So that our MODIS. This MOSDEC, you can Google it, MOSDEC SEC, you will get the data from there also. IMD is providing the data. Then these individual satellite, if you can, Google it, you will find like GPM data you get. All these satellites, whether I'm talking about the GPM, Suomi NPP, SMAP, OCO3, Carbon, the ISAT2, then ESMOS, then JSON3, then SWOT. SWOT is going to launch very soon. This is surface water and ocean topography satellite, which is going to be launched soon. Then global ecosystem dynamics investigation. Then eco stress, it is already launched, which provide the water information. Then of course, cyclone global navigation satellite system, surface wind speeds in the inner core of tropical side it provides. So there are many satellites, and I'm sure, and these satellites will provide the direct data for that climate studies. So this is what I want to tell you, that how important it is to understand the climate, because climate is going to influence our day-to-day life. It is already influencing. We are having extreme climate system. Sometimes it is very, very peculiar phenomena I found in last 25 years when I studied that in a single, at single place in a single year, you find same place a drought as well as the flood. And this is very peculiar. It is happening because of the climate change. So climate change is going to influence our day-to-day life. And it is very, very important that we should know the subject. What is a climate system? What is the indicators? And what impact will happen over our day-to-day life. So this is all I want to tell, and I wish you all the best for successful completion of this course. Thank you very much.
Thank you, sir. Thank you, sir.
Thank you so much,
sir.
sir. Thank you for your wonderful words and for highlighting so many important points that is very, very important to understand before we start this certificate course, because it is very important to understand these things from the people who are expert from this field, that why we have to understand climate. And few minutes back, you just said that, climate is influencing us. It is already influencing us, and we can see that. So thank you so much for touching upon very intricate details of climate and climate change, and that why it is important to understand that how this very important tool, that is remote sensing and GIS, can be implemented and used in the modeling of climate and climate change. And the information that you have given to us about the satellites and how we can use those data in the prediction and projection is very appreciable, sir. Thank you so much for honoring us today, for being with us today and taking time for us. Thank you so much, sir. On behalf of the entire organizing team and Amity University of Uttar Pradesh, I extend my heartfelt gratitude. So
Thank you, sir. Thank you so much, sir, for facing this occasion. Thank you, sir. But sir, next time we will invite you in the offline mode so that our students get the maximum benefit from your experience. Thank you, sir.
indeed,
Thank you.
indeed. Thank you so much, sir. Thank you so much. So, ladies and gentlemen, with this, we come to the end of our inaugural program, but we have joined by Dr. Tanu Jindal, Group Additional Pro Vice Chancellor, R&D, Amity University, Uttar Pradesh, India. So, I request ma'am to say a few words to the gathering before we close our inaugural program. So, Tanu ma'am, over to you.
Yeah, thank you, Dr. Ambrina. Thank you.
Thank you.
So, speaking of all the dignitaries, Dr. S.P. Agrawal and Dr. Mrityunjay Mahapatra, and I have also heard our Vice Chancellor, Dr. Bandyopadhyay, Dr. S.P. Singh. I think there is very less to speak, but I would say that, that this is very timely training course which you have, certificate course which you have launched, because remote sensing has become almost a necessity to understand climate change. Climate change is a very vast phenomena which has been across the globe, and I think remote sensing technologies can only contribute to it, to know it fully, to know it completely, owing to its the panorama of the climate change issue. And our honorable founder president sir has always encouraged us to do research in global warming and climate change. He has launched a cluster on global warming and climate change, which we are running across the Amity University campuses. In fact, the research has been done using remote sensing technologies in large number of projects. So, and our dynamic chancellor is also very tech savvy, and with the Amity global campuses, we are now increasing this research even in our abroad campuses. So this is a very, very important technology, which which we cannot just ignore. In fact, we cannot even live today with this kind of technology. So I would say that having trained in this kind of technology of remote sensing in climate change, this will give us understanding how the phenomena are happening for global warming. Plus, what are the measures we can take to stop the climate change? Gaps we are identifying. So it is not only important to understand climate change modeling. I think next time we'll do something together on how it is, remote sensing applications can tell us about the impact of adaptive strategies which we are having. So it is not only about knowing the level of climate change, the modeling, the pollution, the global warming, but I think we have to go one step ahead in terms of research. Recently, I attended a meeting with NICES and with ISRO, a meeting on application of remote sensing in environmental studies. So in that, we have identified certain gaps also where remote sensing can be applied. For example, lightning system, cloud burst prediction, right? So there are many areas, forest fire, early warning system, how we can also, what is the impact of forest fire. So there were around 16 gaps were identified where we can further pursue research using these remote sensing technologies to understand global warming, climate change, also early warning system because of the climate change. Also, it enables to monitor the Earth's surface, ocean, and the atmosphere at several spatio-temporal scales. And it does allow climate system observations as well as to investigate climate-related processes or long and short-term phenomena. So there are many examples, for example, processes of deforestation or El Nino trends. Moreover, it is also useful to collect information, data in dangerous situation, for example, fire events. Also, it is inaccessible areas like impervious areas. You can collect the information through remote sensing. It is also related to climate change adaptation practices, which include natural resource management, management of agriculture practices, that is very widely been researched, and there are many research scholars who are working on this particular topic on management of agriculture practices, and also to see the impact of climate change on agriculture yield. So also it has been used for land conservation and soil carbon stock, then tactical forest fire fighting operations in real-time decision support system, that can be done. Then monitoring of land cover. In fact, one of our faculty has studied urban sprawl using this remote sensing technology. But we can also use this technology for afforestation, deforestation, such kind of data. So land cover can be easily analyzed using this remote sensing technology. Then further, I would say carbon stocks and related dynamics can also be utilized using remote sensing technologies. Plus, we can also use this technology for improvement of climate projections. So that can be done, and also meteorological real analysis products. This can be done. Now, since I'm working in Antarctic region also, we have been using this technology to know the snow melting, the glacier melting, how much is the glacier melting or snow melting, and how much is the sea level rise. So this is also one of the technology which application which we are doing for remote sensing. So I would say remote sensing is is the future, and everyone must know. In fact, I'm compelled to learn more about it, being a toxicologist. But since it has large number of applications, remote sensing and technology, I have learned it. I've learned many technologies. I would keenly attend many of the sessions which you are carrying out over the span of 1 month time, and it is very exhaustive training which you are doing. I congratulate you for organizing such wonderful 1 month online certificate course, which is must to do, and that too with a very nominal registration fee. So it is, I think I would request all the students, all the participants, faculty to make use of such opportunity. I myself will try to attend large number of sessions. And I once again thank you, our chief guest, Dr. S.P. Agrawal, and our guest of honor, Dr. Mrityunjay Mahapatra, and wish you all the best for a 1 month's time to conduct this course smoothly and with large number of participation. Also try to identify the gaps, which we can cover in climate change using this technology. Thank you so much.
Thank you so much, ma'am, for your best wishes and for that wonderful address. Thank you so much, ma'am. Thank you. So with this, we have come to the end of our inaugural session for 1 month certificate course. Now, I would request my colleague, Dr. Anamika Shrivastava, Assistant Professor, Amity Institute of Environmental Sciences, to please give the vote of thanks to the August gathering.
Thank you so much, ma'am. A very good afternoon to all the respected dignitaries, esteemed speakers, faculty members, research scholars, and the participants across the country. On behalf of Amity Institute of Environmental Sciences, Amity University, Uttar Pradesh, and India Meteorological Department, I, Dr. Anamika, along with the entire organizing team, extend my heartfelt gratitude to one and all present here for joining us today in the inaugural session of online 1-month certificate course on basics of remote sensing application in climate change modeling, organized by Amity University in collaboration with India Meteorological Department, which is to be held from today, 18th of August to 19th of September, 2022. I, on behalf of the entire fraternity of AIES and IMT, would like to convey my deep regards and thanks to Honorable Founder President, Dr. Ashok K. Chauhan, the Founder President, Ritnan Baldev Education Foundation, and Amity Education Group for his continuous guidance and encouragement. It is his vision and leadership that has placed Amity University among the top universities in the world with the vision and mission of making India a superpower in education. We are grateful to the President and Chancellor, Dr. Atul Chauhan, sir, for his guidance and support. We extend deep and sincere regards to our Honorable Vice Chancellor, Dr. Balvinder Shukla ma'am, for her incredible leadership, guidance, and support throughout the execution of this certificate course. We are thankful to Dr. D.K. Bandyopadhyay, Chief Advisor, Founder President Office, and Chairman, Amity Law School and Amity School of Engineering and Technology, for having graced us with his August presence despite his busy schedule and multifarious commitments. We offer our sincere thanks to Dr. S.P. Singh, sir, Director, Amity School of Natural Resource and Sustainable Development, for his continuous guidance and support. We will also express our thanks to the Joint Coordinator, AIES, Dr. Renu Dupa, for her tireless efforts in preparing for this 1-month online certificate course and constantly being with us every day at every moment. We sincerely thank our chief guest, Dr. S.P. Agarwal, sir, Director, Northeastern Space Application Center, Department of Space, Meghalaya, for gracing this occasion and sharing his valuable experiences with us. We extend our gratitude to the guest of honor, Dr. Mrityunjay Mohapatra, President, IMS, and Director General of Meteorology, India Meteorological Department, for gracing this occasion and for a truly inspiring session. We extend our thanks to Professor Tanu Jindal ma'am, Group Additional Pro VC R&D and Director AITSM, for her encouraging words and insights on the topic. We are thankful to the scientific and administrative team members of AIES and IMT for their continuous hard work and support. We are also thankful to the faculty and students of AIES for their support and help. We also humbly acknowledge the support of administration staff, especially the IT and media personnel. We would like to thank the esteemed delegates, scientific communities, colleagues, and research scholars for being an integral part of this international event. Last but not the least, we would like to thank Almighty God and everybody who has directly and indirectly helped us. Thank you, everyone. We will meet again shortly after this session for the beginning of the next session. Thank you, everyone. Over to you, Amrina ma'am.
Thank you, Anamika, for that wonderful vote of thanks. Now I request everybody that we'll be meeting again at 1, and the session link is already being mailed to the participants. So the participants will be joining again with the another link, which is for the sessions. And this link will be active for the entire month because the inaugural session link would be expired by 1 p.m. So I would request everybody to join us at 1 through the link, which is already being mailed by one of our team member, Mr. Naresh. So from here, I'll take leave of everybody, wishing everyone all the best, and looking forward to the wonderful sessions that we're going to have in the coming month, because every Thursday and Friday, second half is given to the various sessions so that most of the people can make best and get the best of the efforts that Amity University is putting up. So thank you so much, everyone, all the respected dignitaries, faculty members, staffs, participants, to be to be with us today at this moment. Thank you so much.